Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina binti MD Pauzi. My metric number is S57798. Today I'm going to present about ocean ion fertilization, OIF. The world now faces a very critical problem of global warming. There are various ideas and approaches that has been proposed to alleviate and resolve this problem, and one of the most attractive methods is ocean ion fertilization. So, what is ocean fertilization? It is a method used to reduce carbon dioxide levels in the atmosphere by fertilizing nutrients such as iron, nitrogen, and phosphorus into the ocean to stimulate phytoplankton growth. Phytoplankton then absorb carbon dioxide for photosynthesis and also export the carbon to the deep ocean or sediment through ocean biological pumps. There are very significant differences regarding the composition of atmospheric gases in the present and the past, where the composition of carbon gases in ancient times is lower compared to today. To find out about the atmospheric gas composition in ancient times, various analyses have been performed, including analysis of trapped air bubbles in Arctic-Antarctic ice core, where it has revealed that atmospheric carbon dioxide is 180 ppm during the last glacial maximum, which is about 20,000 years ago, was much lower than during pre-industrial times, which is 280 ppm. Dust inputs are generally regarded as a major natural ion source for ocean fertilization, and Martin hypothesized that during the last glacial maximum (LGM), increased dust input relieved ion limitation and thereby substantially enhanced the biological pump in high nutrient low chlorophyll (HNLC) region, particularly in the Southern Ocean. The main objective of ocean ion fertilization is to focus on artificial addition of iron to HNLC region as a means of enhancing carbon fixation and subsequent export via the biological pump. The area to conduct this ocean ion fertilization experiment has been specifically selected, which is in the subarctic North Pacific, Equatorial Pacific, and Southern Ocean. These places are chosen because it's known as a high nutrient low chlorophyll (HNL) region, where phytoplankton cannot fully use the available macronutrient, particularly nitrate, for photosynthesis due to lack of iron. It can cause primary production in this HNLC region is relatively low, even the high availability of macronutrients, in particular nitrate and phosphate. Is there any relationship between iron content in the ocean and carbon content at the atmosphere? Okay, the presence of iron actually can influence ocean productivity. Iron can control the ability of phytoplankton to absorb other nutrients. So, with the presence of this iron, it can stimulate the growth and reproduction of phytoplankton more quickly because the absorption of phytoplankton to nutrients occur very well. Then, these organisms consume carbon dioxide from the atmosphere as they photosynthesize. High iron causes higher productivity in the ocean, and with more productivity, the biological pump sequesters carbon at a faster rate. Less carbon in the form of carbon dioxide and methane causes further lowering of global temperature. On the other hand, iron can stimulate the absorption of nutrients by phytoplankton. So, less iron in the ocean can cause phytoplankton to not be able to absorb nutrients properly, which will result in their growth and reproduction being slowed down. The number of phytoplankton will decrease, and as we know, phytoplankton photosynthesize by absorbing carbon dioxide from the atmosphere, and this can reduce carbon from the atmosphere. But with less phytoplankton, the absorption of carbon dioxide from the atmosphere will decrease, which will cause carbon dioxide in the atmosphere to remain the same, or worst of all, increase. This can increase global temperatures. As you can see here, these are 13 artificial ocean ion fertilization experiments that has been conducted. So, these are 9 unsuccessful artificial ocean ion fertilization experiments and its limitation on why they were unsuccessful. It is because no export flux measurements in the deep ocean, insufficient experimental duration, high dilution rate by small patch size, and single ion addition. Out of 13 artificial OIF experiments that has been conducted, there are 4 experiments that are recorded to be successful, and they are ASEN EX, SOFEX N, AFEX, and Series. This experiment is said to be successful because after OI test, primary productivity is rapidly increased. This is due to the concentration of chlorophyll A has increased. The atom bloom can be caused by increased chlorophyll A concentration due to nitrogen loading. The diatoms will produce high amount of oxygen, indicating a high rate of photosynthesis. A variability of silicate is linked to the changes to a diatom-dominant ecosystem. However, if the amount of silicate decreases as a result of increased phytoplankton gradient pressure, diatom bloom will rapidly decline. As we know, out of 13 experiments conducted, only a few were successful. This is because there are some limitations that we are still cannot overcome. So, for future OIF experiment, we must make some changes and improvement to overcome all the limitations so that this experiment succeeds in achieving the desired target. Among the improvements that can be made or done are: first, project or experiment in future should follow the guideline formulated by the LCLP. Second, future artificial OAF experiment should be conducted by carefully considering the major factors including the method for ion addition, tracing method, measurement parameters, location, timing and experimental duration under international artificial OIF regulation. Third, use the fundamental information and knowledge from previous artificial OIF experiments to improve understanding of southern pelagic ecology, which is biogeochemistry. Fourth, experiments are conducted in the center of an eddy structure where grazing pressure is low and silicate levels are high. Fifth, shipboard observations are made during a minimum of 40 days with multiple ion injection. 6. Use both physical and biogeochemical to trace the ion fertilization patch. And last but not least, monitor the side effect on marine ecosystem, including decline in oxygen content and the production of climate-relevant gases and toxic GA using optical sensor-equipped autonomous morph-profilers and or autonomous benthic vehicles. There is also a plan for future OIF experiment known as Korean Iron Fertilization Experiment in the Southern Ocean, KIFES. The KIFES design entails a 5-year project plan model on the EFEX program that found deep carbon by conducting an artificial OIF experiment in the center of an eddy structure. So these are the goals and objectives for KIFES according to the plan year. Uh, These are the goals and objectives for Year 3, Year 4, and Year 5 plan. These are 4 references that I use, including the article given. Okay, I think that's all from me. Thank you.